Okay, in your chapter 3 review, as we look at number 1, it says that it wants us to go ahead and solve log base 4 of x plus log base 4 of x plus 3 all equals 1. So remember your very first step that you want to do before you solve any logarithm, you want to make sure and condense the logarithm together. So notice this is a plus sign right here. So if we remember correctly, a plus sign with our logarithms means multiplication. So remember your rule that you're going to go ahead and just write the word log one time only. So we've got log base 4. Now to condense this together, we change our plus to a times sign, and we end up with log base 4 of x times x plus 3 all equals 1. So our first step is to go ahead and condense that logarithm together. Now that I've condensed it together, I can go ahead and solve this. So notice I've got a log base 4 right here. So its opposite is a base 4. So I'm going to base 4 both sides. And when I base 4 both sides, I get 4 to the log base 4 of x times x plus 3 all equals 4 to the first. Now that I've based both sides, notice that these log base 4 of 4 is going to cross out. And I'm just going to be left with x times x plus 3. And 4 to the first is going to be 4. Now that I've gone ahead and changed it, I've got an algebraic equation here. My algebraic equation says I've got x times x plus 3 all equals 4. So now I'm going to go and distribute the x on through. So x times x is going to give me x squared. X times 3 is 3x. And I still have this all equaling 4. Now I'm going to go ahead and subtract 4 from both sides. I'm going to move this 4 over here. And I end up with this equation, x squared plus 3x minus 4 all equals 0. Now that I've done that, I'm going to go ahead and factor my equation. So the factors of negative 4, which is 4 and negative 1, that add up to be that middle, which is 3. So I factor this down to x plus 4 times x minus 1 all equals 0. So I end up with these two answers. I end up with this answer of x equals negative 4 and also x equals 1. Now remember, logarithms cannot be negative. So if I was to substitute that negative 4 into the original equation, I'd end up with a negative logarithm. And so since I have that, I have to reject this negative 4 as an answer. And so then I end up with my answer of x equals 1. On this next problem, you just want to be able to identify this graph. And it says we got f of x equals 5 to the x. So remember, with an exponential function, you have your main point at 0, 1. And so my first step is to go ahead and put my dot at 0, 1. And then remember, it has that asymptote that is going to be 1 below the main point. So remember, this is 1 below your main point. And so 1 below the main point is going to be at y equals 0. So I go ahead and I put in my dotted line. Here is 0. And then I just go ahead and draw in my basic shape. And remember, it's going to be going up as you go from left to right. So as I look at those answers to see which one it matches up with, so you're going to remember that when you do it on your calculator, it doesn't exactly look like that line is there, but it does match that graph of B. So this testing program, same thing as your calculator, makes it look almost exactly like that line. Okay, on this next problem, on example 3, it wants me to go ahead and sketch the graph of this function. So again, sketching your graph of your function, remember the first thing you want to do is go ahead and write down your main point. Your main point is at 0, 1. So all exponential graphs have that main point of 0, 1. Okay, now I'm going to go ahead and take a look at my shift. So my shift is occurring right here. And so when I solve that equation, I get 1. And then this would be my y shift of negative 2. So I go ahead and put my x and my y shift underneath my main point. I'm just going to add these together. So I get 0 and 1 is going to give me this positive 1. And 1 and negative 2 is going to give me this negative 1. So there's my new main point at 1 and negative 1. So to graph this, I go to my main point, which is at 1, negative 1. So here I am at 1, negative 1, put my dot there. Remember your asymptote is 1 below that main point. So I go 1 below it, and I put in my dotted line. And then I just draw in that basic shape. And so that is what number 3 would look like. F of x equals 2 to the x minus 1 minus 2. That's what its graph would look like. Okay, looking at this next equation here. So on this next number, on number 4, it says if $9,000 is invested in a long-term trust fund with an interest rate of 8.8% compound continuously, what is the amount of money in the account after 15 years? So I need to remember that continuous compounding is this formula right here, A equals P, e to the RT. I need to remember that P is going to be your principal or your original investment. E is going to be that number 2.718 that's built in your calculator. So R is your rate, and then T is going to be the time. So now to go ahead and solve this problem, I just need to remember that my principal, or my original investment, is $9,000. So I go ahead and substitute in 9,000 in place of P. So notice I went ahead and substituted in 9,000. E is that number in your calculator. And then it gives me a rate of 8%. Don't forget to change that to decimal. That's 0.08. And then your time is going to be for 15 years. So once you're done doing that, you can just take your calculators. So on your calculator, you're just going to go ahead and type that in. So I'm just going to go ahead and type in 9,000. Hit second function, hit my E key, which is above the ln, and then go ahead and type in the 0.08, and then times 15. Hit enter, and it looks like that answer comes out to be $2,981.06. And that matches the answer on C. On number 5, it says identify the logarithm equation written in exponential form. So remember, to write this in exponential form, there's 2 ways you can do it. The easiest way that most students start to rewrite things is they just remember that, do the opposite, I mean, base 64 both sides. To get rid of that log, so that crosses out. And so then you're just left with your base of 16. And then you've got your other side, which is 64 to the 2/3. So that's an easy way of changing things over to its exponential form of 16 equals 64 to the 2/3. And then you can just go ahead and use your commutative property and just rewrite that. So it says we got 64 to the 2/3 all equals 16. So that matches the answer of A. On number 6, whenever you read anything that says evaluate without the aid of a calculator, that means that it can go into that problem evenly. So notice the very first thing that I do is I go ahead and separate this out. And I remember that division means subtraction. So since division means subtraction, I rewrite my equation as log base 4 of 1 minus log base 4 of 64. Now I can solve each one of these separately. So solving each one of these separately, I know that log base 4 of 1 is, the answer to that is 0. Because this is basically asking me 4 to what power is equal to 1. And so that would be 4 to the 0 is equal to 1. And so that answer would be 0. I got log base 4 of 64. So 4 to what power is 64? So that answer is 3. So now I got 0 minus 3, so that answer is going to be negative 3. Now if you can't remember to what power of 4 is 64, you'll notice that you can do what's called a base tree. In other words, I write down my number 64, and I take 4 out of it. That's 4 times 16. And then I do my next tree, which is 4 and 4. So there's all my bases. I've got 3 bases of 4, so that is going to give me 4 to the third. So that's one way that you can figure out what power is equal to 64 when you have your base of 4. You can do what's called a base tree if you can't remember that. And then you can go ahead and find your answer. So the answer to that one is going to be negative 3. So that answer is B. On this next problem, on number 7, it just wants you to put it in your calculator. So to put this into your calculator, you're just going to go ahead and take your calculator, type in the ln, and then type in 1 plus the square root of 5. Make sure you get out from under there, put your other parenthesis there, hit equals, and your answer comes out to be 1.744 when you round that off to the third decimal place. On number 8, it says the number of units sold for a certain product is N equals 1,500 times the ln of 7t plus 9, where t is the number of years after the product is introduced. What are the expected sales 9 years after the product is introduced? So with this problem right here, you're going to notice that your t is equal to 9. So go ahead and substitute in 9 in place of t. And after you're done substituting that in, you can just go ahead and type that into your calculator. So take your calculator, go ahead and type in and let's see if I can get my calculator to stay over here. So now I've got, let me go ahead and clear out this other thing. So I've got 1,500. And then I've got parentheses, or ln, and then type in 7 times 9 plus 9. Hit enter, and so it looks like your answer comes out to be 6,414.99. So that's going to round off to 6,415 units. So that answer looks like it's going to be C. On my next problem, on number 9. So number 9, I've got log base 2/3 of 13. It just wants me to evaluate the logarithm using the change base formula, find the value to 3 decimal places. So remember, your change base formula just says the following. It just says that if you have log base a of x, put it in your calculator, you're just going to take log x. So log of the top divided by log of the bottom. So log x divided by log a. So put that in, you got log 13 divided by log 2/3. Put that into your calculator. So putting that into your calculator, clear that out of there, and we're just going to go ahead and type in log 13. And then we're going to divide that by log 2/3. Hit enter, and that comes out to be negative 6.32594. And so you go ahead and round that off to negative 6.326. Okay, on number 10, it just says indicate whether the following statement is true or false. So this false, correct the statement. It says log base 10 of 8/7 is equal to log base 10 of 8 divided by log base 10 of 7. So remembering our laws of our logarithms, we know that division means subtraction. And so that answer would be false. So log base 10 of 8 divided by 7. So that answer would be log base 10 of 8 minus log base 10 of 7. On number 11, we've got an exponential equation here. And it says we got 4 to the 2x minus 2 minus 28 is all going to equal negative 12. So if you remember correctly, the very first thing that you want to do is you want to take care of your algebra. So here's your algebra part right here, minus 28. So we're going to add 28 to both sides. So adding 28 to both sides. Negative 12 plus 28 is going to end up being 16. So now we've got our equation, 4 to the 2x minus 2 all equals 16. You're going to notice that is an exponential equation. So we've got to do the opposite of a base 4. We have 4 to the 2x minus 2 equals 16. So now doing the opposite of a base 4, that means I'm going to log base 4 both sides. So log base 4 both sides. So I put log base 4 on this side, log base 4 on this side. Okay, when I'm done doing that, notice these two cross out. I'm just going to be left with 2x minus 2. And log base 4 of 16, there's two ways to solve this. You can put it in your calculator using your change of base formula. So you can use your change of base formula right here to actually figure out what log base 4 of 16 is, or you can actually do this one mentally. But if you need to, put it in your calculator using your change of base formula. But I know that 4 to the second power is 16, so that's why this right here, log base 4 of 16, becomes 2. Now if you need to, you can put that in your calculator using your change of base formula. So using your change of base formula, you can just go ahead and type into your calculator. You can type in log 16. So type in log 16, read that wrong, divided by log 4. And that answer is 2. Okay, now that you've done that, now you're back to some algebraic parts. You got 2x minus 2 all equals 2. So I go ahead and add 2 to both sides, getting rid of my minus 2 for my algebra. So I get 2x, 2 plus 2 is going to be 4. And I divide both sides by 2. And you get x equals 2 as your answer. Okay, on problem number 12, the directions say use the properties of logarithms to expand the expression. Assume all variables are positive. So it gives the problem log base 2 of x to the 9th times the cube root of y. So we need to remember that, in this case right here, that multiplication means addition. So everywhere I see a multiplication sign, I'm going to go ahead and put an addition. So separating this out, I take this right here, I get log base 2 of x over 9. And I'm going to rewrite that as log base 2 of x minus 9. Minus means plus. And then I got log base 2 of the cube root of y. So separating that out with a plus sign. Okay, now I remember that I need to put all my exponents out in front. So putting this exponent out in front. So here's my 9. So my 9 is going to go out in front. So that leaves me with 9 log base 2 of x plus. I need to remember that the cube root of y is equal to y to the 1/3. So remember, all of your roots are actually fractional exponents. So that 1/3 is going to go out front also. So that becomes 1/3 log base 2 of y. And so that's how you expand out your logarithm. So you end up with your answer of 9 log base 2 of x plus 1/3 log base 2 of y. Now this next problem on number 13, it says it wants me to condense this logarithm expression. So to condense this together on this next problem, on number 13, I notice I've got 4 log base 3 of x plus 6 plus 4 log base 3 of x plus 4 minus 1/2 log base 3 of x. So remember your rule, make sure that you write your word log one time only. So notice all these log base 3's are in each expression. I write it one time only. So I've got log base 3 of that I write one time and one time only. So on this next thing that I need to remember my rules. And my rules just basically says the following. So addition means multiplication, subtraction means division, and your numbers out front become your exponents. So remember those rules as you're working through this problem. So on this problem right here, as I look at it, I'm going to condense it together. So first thing I notice is that I have this plus sign. So this plus sign becomes multiplication. Now all these exponents are going to go up top here. So you're going to notice that this 4 goes up top and becomes x plus 6 to the 4th. And this becomes x plus 4 to the 4th. And then this minus sign right here means division. So here's my division. And then this 1/2 power is going to go up top. So that becomes x to the 1/2. So if you want to, you can just go ahead and leave this as your answer. Your answer would be log base 3 of x plus 6 to the 4th times x plus 4 to the 4th, and then that's all divided by x to the 1/2. Or you can also rewrite that x to the 1/2 if you wanted to. We know that a half power is also a square root, so this becomes the square root of x. Either one works, so that's why I put the or there. You can write it either way is perfectly fine. I'll accept either answer. Okay, on this next one, on number 14, it says I've got 1 over 25 equals 125 all to the 3x plus 5. So you're going to notice on this problem right here, it's actually written backwards. In other words, this side is your base, here's your exponent, and this is what it equals. And so basically I just have to remember that I'm wanting to solve for x, so I need to get x by itself. So I'm just going to go ahead and log base 125 of both sides. So when I do log base 125 both sides, I end up with log base 125 to the 125th all equals log 125 to the 125 3x plus 5. So now remembering my laws of exponents, my logarithmic laws, that means that this is going to cross out. And so I'm just left with 3x plus 5. And then on this side, over here, I've got log base 125 to the 125th. So I'm going to go ahead and use my change of base formula. So my change of base formula just says that I need to take the log of 125 all over, log of 125th all over log of 125. So here's your change of base formula. You're just going to want to go ahead and use your calculator. So put this into your calculator. So typing into your calculator, in my calculator using my change of base formula. So I type in log, and I got 1/25th. And I'm going to divide that by log of 125. Okay, so it looks like I got negative 0.66666. So if you want, you can actually change that to a fraction. And the reason why you might want to change that to a fraction right now is because it does come out to be a fraction. Or you can just continue on. So you end up with your negative 0.6666 all equals 3x plus 5. Then you can go ahead and just subtract 5. And then you can divide that by 3. And you can do that all in one step on your calculator, because then you can just hit your math key, hit your fraction, and that changes it to negative 17/9. So that matches up with your answer of, it looks like, answer D. Okay, on this next problem on number 15, continuing our solving our equations on number 15, it says we got 6e to the 0.03x plus 45 equals 46.2. So getting rid of your algebraic parts first, we're going to go ahead and subtract 45 from both sides. When I subtract 45 from both sides, I end up with this answer of 1.2. So now I have 6e to the 0.03x all equals 1.2. So still getting rid of my algebra, I'm going to divide both sides by 6. And when I divide by 6, I end up getting this answer of e to the 0.03x all equals 0.2. So now I have to remember that the opposite of e is going to be ln. So I'm going to ln both sides of my equation. So this crosses out, the l and e are opposites of each other. And I end up with 0.03x all equals the ln of 0.2. Now I'm going to divide both sides by 0.03. So dividing both sides by 0.03. So I end up with the ln of x, the ln of 0.2 divided by 0.03. So dividing by 0.03, putting that in my calculator. I've got the ln of 0.2 and then divided by 0.03. And that looks like that comes out to be negative 53.6479. So I just go ahead and round that off to negative 53.648. And that looks like that matches with the answer of A. Okay, number 16, it says I've got log base 6 of 4x plus 3 all equals 4. So again, solving using the opposite. So I'm going to base 6 both sides, because the opposite of log base 6 is base 6. So I base 6 both sides. When I do that, that crosses out. And I'm just going to be left with 4x plus 3 all equals 6 to the 4th. So I take my calculator, and I take 6 to the 4th. That comes out to be 1,296. So now finishing this off using my algebra. So subtracting 3 from both sides. So subtracting 3 from both sides, I'm going to end up with 4x, 1296, minus 3 is going to be 1293. And then I just go ahead and divide both sides by 4. And dividing both sides by 4, I get 1293 divided by 4. And that looks like that's going to match up with the answer of D. So they don't simplify that down. They just leave it as 1293 all over 4. On this next problem, on number 17, it says the number of bacteria present in a culture is B equals 100e to the 0.461 t, where t is the time in minutes. Find the time required for the nearest half minute to have 1,000 bacteria present. So my first step, I know that B is going to equal 1,000. So I go ahead and substitute 1,000 in place of B. So now solving this equation, just doing the opposite. So I divide both sides by, so notice I'm solving for t, solving for time. So I divide both sides by 100. So when I divide both sides by 100, I end up with 10, all equals e to the 0.461t. Okay, now I know that the opposite of e is ln. So we go with ln both sides. So notice I take the ln of both sides, and I get the ln of 10, all equals the ln of e to the 0.461t. That's going to cross out. And I'm going to end up with this equation, the ln of 10, all equals 0.461t. So now I go ahead and divide both sides by 0.461. And then I just go ahead and put it into my calculator. So putting that in my calculator, I've got the ln of 10, and then divided by 0.461. And that looks like that's going to come out to be 4.99476. So t is approximately equal to that. And so that looks like that's going to leave me with the answer of D, 4.99, all equals t. So I just round it off to 5. minutes. Okay, on this last problem here, I've got 3 ln of 3x, all equals 21. So getting rid of my algebra first, I'm going to divide both sides by 3. So I've got 21 divided by 3 is going to equal 7. So continuing on, I've got the ln of 3x, all equals 7. Notice that 3x is tied in together. You're solving the equation, you're just kind of collapsing it down on itself. So the opposite of an ln is going to be e. So I take e of both sides. That's going to cross out e to the ln. And I'm going to end up with 3x, all equals e to the 7th. Now I'm going to divide both sides by 3. And then I'm just going to go ahead and put it into my calculator. So dividing by 3. I've got e to the 7th all over 3. Now just go ahead and put that in my calculator. So taking my calculator, typing that in, I hit second function, e. I type in my 7. Arrow on over, then divide by 3. It equals, that comes out to be 365.44. Sorry, 365.544, and that is going to be your answer for number 18 is 365.544. So that answer is C.